That's my transducer mark. If we go by this folding paper method and we do this right here, and I'm in 40 feet of water, that means I'm shooting directly under the boat. I'm not seeing anything that's not to the left and to the right in the black. And then the ground picks up and I'm only shooting 40 feet to the left and 40 feet to the right, because you have to subtract the depth of your water, right? Well, that didn't make any sense to me. And so I've done a lot of scanning trying to figure out, that's not right. That's not what I'm seeing when I'm scanning. So the first thing we're going to do with this video is I'm going to take you out. I did some recording in the summer, took a rangefinder out, hit the lake, hit some objects, ranged it with a rangefinder, and then drove by it in the boat. And I'm going to let you see that right now. We're going to debunk this method right here. And we're going to get more to like this, but still this is confusing. Stick around to the end of the video. We're going to trash this little paper folding method, and I'm going to show you what I found out from doing a bunch of scanning and what I believe that I'm seeing. It's not perfect, but it's a lot more accurate and a lot less confusing than this deal right here. So stick around. Let's go to the lake. So folks, what I'm going to do is I'm going to shoot this water tower, concrete cylinder, goes all the way down on the ground. I'm going to range it, this is in yards, to when I get directly in line with it, to see how far, in fact, I am away from the water tower. And I'm going to try to get right in line with actually where my transducer is located, which is on this pontoon right here. So I'm going to shoot it, and I'm approximately 12 yards. So there's 3 feet in a yard. 12, 24, 36.
Width 18, 20 feet.
Blow this up, blow this up, blow this up.
And then there's my 2 Coke bottles. So I passed, again, I'm estimating 18, 20 feet. Let's see what, when I put the cursor on it. 19.3 feet.
Okay, I've got my buoy target set out, 40 foot of water. I've got 2 Coke bottles representing air bladders on fish, suspended 20 feet down. I am gonna go tight as I can get to the buoy without running over it. So I'm gonna, when I say tight as I can get, I'm gonna get within
about 4 feet of it. Well, right here. And that's a mark that I got. That's what I've got on my side scan. It is 20, those 2 bottles are 20 feet down. And that's my transducer. So if I touch that, it was 4 feet to the left. That's exactly about where my transducer was off the buoy. About 4 feet, 4.1 feet to my left. So it identified those suspending Coke bottles precisely to the edge, and 20 feet down. So if the theory of the fish is right underneath the boat at 20 feet, well, here's my marks. I'm gonna put my cursor right in line with, we'll go 20 feet over. So there is my cursor. There's the mark. There's 20 feet. So they're 20 feet down. So should I subtract 20 feet? I see that mark. No, those fish are 4 feet. That's accurate. You waypoint that, go back over it with 2D and down scan, and you got it.
So the first pass, I passed the 2 bottles. The plastic bottles are just filled with air. My 20-foot marker, I passed right at 19, 20 feet away, and they were 20 feet down. And they had an anchor on the bottom and a big buoy at the top on a tight line so that they would, and again, 20 feet, 19 feet, you know, I measured out with a tape measure, so that's pretty close to where they were. And that's right on that break, that threshold that I'm saying side scan views. And this is, again, this is my opinion on what side scan's picking up and my opinion on what down scan is picking up.
I passed by those same Coke bottles 4 feet on that second shot that I added to it, and they were down 20 feet. It wasn't quite as bright of a return, but you could see the return of the 2 bottles. Where did they show up? Exactly 4 feet over when I highlighted the cursor. So do I think you're picking up in here? I think it's a combination of both. If you see a return in here on a fish, a single dot, then down scan's going to pick it up, and 2D is probably going to pick it up.
So if you stuck around this far in the video, do me a favor, hit that thumbs up and hit that subscribe button. I'm not an expert and I'm still learning, and I want to bring you guys along with me as I'm learning the sonar, getting better with it, spending time on the water with it. So here's the sonar screen. Instead of the folding method, mine's a rigid method. This is the screen that you're looking at right here. And if I flip it to where the numbers are right. So again, I'm out to 80 feet, and then I've got a black area. And then I'm 20 feet to here, 40 feet to where it's showing ground on each side, and then 60 feet and 80 feet. This little line right here is my transducer line. So this is what I think is going on when you're reading the side scan. If I take and do this right here and flip it around, the side scan beam, the boat being right here, when you're looking at your screen, this is old, this is the newest data that's coming in. The screen travels this way. So if you are traveling, this is the brand new data coming right off of the boat, or right off the transducer. Transducer's right here, boat's traveling in this direction. So we're going to go right to where the transducer is, and this is what you're seeing. This beam on side scan, because it scans to the side, is scanning all of this perfectly parallel to the top of the water. That's how I'm getting real close to boat docks and picking up boat dock floats, motors, dock parts, the welded beams on the docks. That's because it's up in here. It's right, and I'm getting close to the dock, so it's close to my boat, close to the transducer, 10-15 feet away from it. And again, I'm 40 feet in the water column. But straight down, you can see this triangle right here. This beam travels approximately 45 degrees. When you're in 40 feet of water, then you're 40 feet wide on your side scan. So what's happening with this side scan as it shoots is you're hitting bottom. If it is 40 feet deep, then you are 40 feet this way before it ever starts picking up and hitting the bottom of the lake. So that's what you're seeing when you're looking at this. It finally hits the bottom of the lake, but it's scanning all of this. It's side scan. Down scan picks this up at approximately a 55 degree angle. So there's a little bit of overlap. You're going to see some things on side.